Hello. Today I'm going to be talking about understanding reduce by looking at forEach. Of course, I assume that you already have knowledge about forEach and how it works. Just in case you don't, I'll go over a basic example. So I'm going to start off with a numbers array, 1, 2, 3, and I'll create a basic forEach to just loop over all of these numbers. So I'm going to start at the 0 index, and I'm going to keep looping while I is less than numbers.length, and at the end of this I will increment I, and I'm just going to do a console log of the numbers array at index of I. And so you can see here it's outputting 1, 2, 3. In case you're wondering how this is working, I have an extension installed called Quokka, which I'd recommend everybody installing. It just lets you do some easy live coding, and I'll link it in the comments below. So now I'm going to rewrite this for loop as a forEach, and I'll take the numbers as my input for each, and that's going to give me a number. Each one of these numbers I'm going to console log out. Okay, great. So I definitely prefer forEach over a for loop, just because you don't have to deal with all of this extra stuff. I don't have to worry about indexes, lengths, incrementing indexes again. But again, I'm not going to go into full details about forEach. I'm assuming that you already know the ins and outs of this if you're looking at this video. If not, I'd recommend understanding a forEach completely before diving into reduce. So now one of the mistakes I see a lot of people making with this forEach is accessing outside state. So for example, if I wanted to take each one of these numbers and add them up, I could say let total, I'm going to start that off as 0, and then in here inside of the forEach I'll say total equals total plus number, and that should give me the new total, which is 6. The reason I don't like this is because this function here inside of the forEach is actually reaching outside and mutating this value. So this value is constantly changing with each iteration. In addition, this function is no longer pure, it's a little bit side effecty. And none of this is reusable. All of this code here will just work for this instance, and I can't reuse this stuff anywhere else. So of course what a lot of times we do is we create a function. I'll call it add, and I'll give it our input. And what I could do is take all of this, let's say I'll return the total. I can loop through each one of our inputs. And now if I call add with our numbers, I should see 6. Okay, so this is a great way of kind of encapsulating, creating a pure function that is add with this kind of nightmare code that's inside. And this is a decent solution, but one of the reasons I don't like this is we're creating a function to add when we could be using reduce. That the function to do this already exists. So what I'm going to do is I'm going to put the code back just so it runs again, and I'm going to compact this into a reduce. So now the difference is with reduce. Let me copy this. Okay, so I have my copy of the function. I'm just going to rename this to reduce. I'm going to add the initial value here, 0, into reduce itself. So reduce is now taking 2 arguments. One argument here is the callback function. The second argument is the initial value. Now the reason why you pass an initial value is because reduce can output any type of object. It can output a string, an array, a number, an object, whatever you need to manipulate. Reduce will let you control the shape of that. So in this instance, the shape that I want to output is going to be a number, and the initial value is going to start with 0. So with the same way on line 3 that I set total to 0 here, I'm going to set it in the reduce function as the second argument. So you just do comma and then the initial value. So now I've gotten rid of this line. I no longer need that. I'm just going to comment this code out just so it's a little bit less confusing. And we can see here I'm trying to update the total, which no longer exists. Now with reduce, what we do in comparison to forEach is return the value. So you can see here in forEach, my accumulator is called total, and I'm accumulating the total of the numbers each time through the loop just by setting it using equals. Now the difference with reduce is I don't have access to the total here. What I do have access to is the total as an argument. So you just add one more argument before your number, and instead of setting total, what I'm going to do is return total plus number. Now with forEach, if I were to, let's say, return something here, forEach would ignore this because it doesn't accept any sort of return value in the callback, as well as this forEach is just going to return undefined itself. But with the reduce, what I want to do on each iteration, every time it goes through this, is return the new value for total. So if I were to look in here, I can see the first time we run this function, total is 0. The second time it runs, it's 1, which would be 0 plus 1. And then the next time it runs, it's going to be 1 plus 2, which is 3. Now we're not seeing the final value. We're not seeing all of them together here because that is actually what this returns here. So now if I were to look at total here, I can see total is 6. Now to me, because I already understand reduce, and eventually you, because you will eventually understand reduce, this function becomes a lot easier to read for me than this. And what I was talking about before about reusability is that because this is just a function, I can actually just hit Control X on this thing and say, create the function out here. Now I'm just going to say, I'm going to reduce my numbers, and I'm going to use the add algorithm to reduce the numbers, and I'm going to set the initial value or the shape of the object as 0. And of course, you know, with numbers, I could simplify this down into an arrow function expression. Of course, I can put this in an external library. Now, anywhere in my code base, in other files, I can import this and have the same functionality as opposed to copying and pasting these things around. Okay, so let's get rid of this. So now what I was saying before about changing the shape of your output, whereas filter and map are only going to output an array, reduce will let you change the shape of the output to be anything you want it. So it can be an array, it could be a number, a string, an object, you can output a function. But in this case, I'm going to demonstrate how to do this, and I'll output a typical hash map table object. So let's say I have an array of letters instead. And what I would like to do is just count each of the letters. So I'm going to have one A, two B's, and one C. So I'll go ahead and leave this here. And what I want to do is say I have a counter, and that's going to take in my table and the item. So here I'm just going to do absolutely nothing. I'm just going to take the table as an input and return the table. And I'm going to take my letters, I'm going to reduce them down using my counter, and I'm going to pass in my initial shape of an empty object. So now you can see here I'm passing this empty object in and I'm getting the empty object out, and that's because I'm just returning the table every time. So you can see here it loops through 4 of these, and each time table is empty. So much like having total that we were incrementing, this time we're going to be modifying the table. So what I'll do is I'm going to say table, and I'm going to pass in my item, which is going to be the key of the table. And for now, I'm just going to say it equals hello. So this is what I'm looking at here. I have an object with keys A, B, and C, and each of the values of those is hello. So I can change that by just saying 0. Now we're starting to count. Of course, they're all going to have at least 1 if we've entered through here, but I want to be able to count that last B. So let's see what it looks like if I were to just say table item plus 1. We're going to get a whole bunch of nans as the result, because the first time this is run through, let's say I have, and I'm looking up the key A on X, that's going to be nan, or undefined. So if I were to add 1 to undefined, of course I'm going to get nan. So what I need to do is have some sort of defaults here. So what I can do is, instead of saying just adding to the item, I'm going to take the item or 0. So it's going to, the first time it runs through this, it's going to get undefined. So I'll default it to 0, and then I'm just going to add 1 on the end. I hope this isn't too confusing. You can break that out into multiple things. It's basically the equivalent of saying if the table item equals null, which will capture null and undefined, then it equals 0. And then I can do something like this. So that'll output the same thing. I'm just going to write it all in a single line. I don't think this is overly complex to have a default value here. But now we can see in my output here, there's 1 A, there's 2 B's, and there's 1 C. So let's just make sure this is still working. So why is my copy and paste broken? There we go. 3 B's. I have 1 BC now. Okay, 2 C's. So now a good way of thinking of these numbers is just as state. So I could rename this to state, and this is just a stateful value that starts off as this initial value passed into reduce, and it'll end with the final result here. So the state comes in and you return the state. That's really the only difference between reduce. You always get the item, the state comes in, and then you return the value of the state. With reduce, you pass in the initial value, and the return result is going to be your fully computed value. Now let's look at another example of what we can do with reduce. So we'll take our numbers again, and we'll add some other undesirables that we don't want. So we'll say I have a -5 and just a 4 for fun. So what I'm going to do is I'm going to say with my reducer, what I want to do is I want to pass in an input of numbers, but I want to get back an output that is a count of just the positive numbers. So a lot of times this would be run through a filter first to remove the negative value, but we can actually use reduce to do that also. So I'm going to say numbers.reduce, and I'm just going to call this add positive numbers. and I'm going to seed that with 0 again. So I'm going to create the function add positive numbers. I'm going to have the state and also my number. And let's just return the state for now. And let's see what this value looks like. Oops. Let's write a function properly. So I'm not sure. Oh, that's why it's complaining. Okay, so I'm getting 0. And let's do what we were doing before with just the add. So I'm going to say return the state plus number, and I should get 5. Okay, I think that's correct. So 5. Okay, excellent. But we should not be getting 5. We should actually be getting 10 because we want to eliminate this. So what we can do here is I can say if my number is less than 0, then I'm just going to return my state. Otherwise, I'm going to return the state plus the number. And now I'm actually getting 10. So what I'm doing here is I'm doing a combination of reducing and filtering simultaneously. You can even do reducing and mapping at the same time. So instead of having a number, let's say I passed in an array. So my state here coming in is going to be an array. You can see here on the first run it's an array, but on the other ones it's numbers because I'm outputting a number, which is wrong, right? We want to always output the same shape as is coming in. You don't want to change the state. So let's say if I had state up here as a number, you would never set it to an array and then later on a string. This is silly code. So with the same thing here, you always want to keep it the same shape. So now what I'm looking at is this doesn't have to change because I'm just returning the state if we're less than 0. Otherwise, what I want to do is say I'm going to push a value onto the state, which is just going to be the number. So now I've created a basic filter of only the positive numbers. And you can create a combination of filter and map doing the same exact thing. So let's say this is my filter here where I have to match my number is greater than 0. So I can say is positive number is greater than, let's just say greater than 0. So here I have a function that if I pass in a number, it's going to return me a Boolean of if that number is positive or not. And this is just called a predicate, anything that takes inputs and then returns a Boolean value. So here I've created my is positive, it returns 5 as true and -5 as false. So what I can do here is I can say if it's positive, I'm going to test the input, and I'm going to flip these so that if is positive passes, then I'm going to perform the action of pushing. Otherwise, it's just going to default to returning the state. So it looks like my predicate is working. You can see here I have 1, 2, 3, 4, and no 5. Now if I wanted to add, let's say, a map, I'm going to create a double function, which is just going to take a number and double it. Now I have a combination of my filter and my map. And this is kind of nice. So I have this function that filters and maps, which is a pretty common thing to do, all in one iteration. So as it goes through the array, it's only going to go through one time. Now on an array this small, I'd probably opt to keep map and filter separate and just loop through the array twice. You're not going to see any performance differences. But if you do have arrays that are, in the tens to hundreds of thousands in size, you probably only want to loop through it once, and you want to perform all your actions in the same iteration. So, so this is a little bit of a time saver only for specific scenarios. Otherwise, just go ahead and use filter first and then map and loop and go through the array multiple times. It's not a big deal. So now with this format, because this syntax is so common, there's actually a really creative way of creating these dynamically. And that's what I'm going to create here. I'm going to rename this to filter map. And I'm just going to say this equals filter map for now, because what I'm going to do is I'm going to extract these. This function here is dependent on the isPositive as well as the double functions, and I'm going to try and pull these out and make these a little bit more dynamic, so I can pass in any sort of functions without having to create a new function every time. Let's say I were to create a triple and a quadruple, I'd need to create a new function every time. So this is going to be the generic one that is going to let me pass in any filter or any map. So to pull these out, what I'm going to do is I'm just going to create a function here that is going to return this function. Now this function is going to take a couple of inputs. It's going to take a filter and it's going to take a map. And what I'll do is, where isPositive is, here's my filter map. You can see it's now returning a function, which is the filter map. So I'm going to pass in my isPositive, and I'm going to pass in my double, and I can replace filter here and map here. Now what I've done is I've created a generic filter map reducer that I can use to create other functions. So I can say this is my add positive numbers. Actually, this is no longer add positive numbers, it's double positive numbers. And if I were to create a triple positive numbers, I could easily just add a new mapper, triple, and pass it in here. Now when I reduce it, I could just reduce using triple positive numbers instead of double. So all of that looks right. Let's add another negative number. And I'll create an is negative. Okay. I can create yet another function. Just call it double negative numbers, and I'll pass in is negative, and I'm going to double it. Now when I reduce these numbers down, all I have to do is just pass in another input. So I'm going to double the negative numbers, and here's minus 14, which is that one, and minus 10, which is that. So as you can see, reduce isn't too complicated. It's very similar to a forEach, similar to a map, and it's similar to a filter. All it does is it provides an additional state that comes in along with your input. So mastering reduce can help simplify your code by reducing the number of side effects as well as eliminating mutations in your code. You'll also have code that's a little bit more reusable. So I'd like to thank you for making it to the end of the video. I hope this was entertaining. I hope it was informative. If you did like this video, share it with your coworkers, share it with your friends, like the video. These small interactions tell me to produce more content. And thanks again for watching. See you in the next video.